Before starting the next lesson, try the warm-up. Write an equation to calculate the speed of a vehicle. And then, if Mr. Fisher drove his car 30 kilometers in 23 minutes, how fast was he driving? So pause the video, try it, and see how you do. So hopefully you were able to come up with something like this. Speed is equal to distance over time. So if I'm driving 30 kilometers in 23 minutes, 30 kilometers divided by 23 minutes, that's about 1.3 kilometers per minute. And if you're really keen, you can change this to kilometers per hour, knowing that there are 60 minutes in each hour. So multiply this by 60, it's about 78 kilometers per hour. So the reason I bring this up is we're going to use formulas in our lesson today. So formulas are just equations where you have a bunch of different variables that you'll have to substitute in and solve. So this lesson is all about rearranging formulas. The reason we rearrange formulas is so that we can solve for our unknown. For example, here I have the speed formula that I had you come up with in the warm-up. Speed is equal to distance over time. But now we're going to rearrange the formula to solve for d, the distance. So the reason you would do this is, let's say you know what speed someone's traveling and you know how long they're traveling, but you want to figure out how far they've gone. You would need to rearrange this formula to solve for the distance. So in our formula, speed is equal to distance divided by time. So if I want to isolate d, I need to do the opposite with t. So right now, we're dividing by t. The opposite would be multiplying by t. So we need to multiply both sides by t. So on the right-hand side, we have d multiplied by t divided by t. So those t's cancel each other out. We're left with d on the right-hand side. T times s on the left-hand side. So to calculate distance, it's the time multiplied by the speed. So here we've rearranged the formula to isolate or solve for d. Here's another example. This time I have this formula, v equals u plus at. Now I haven't defined these variables to say what they mean, but for the purposes of this example, it doesn't really matter. We have this formula and we want to rearrange the formula to solve for t. So we need to isolate t. So I have to look at my formula, look at my equation here, and I want to isolate t. There's two other variables on the same side as t that I need to move to the other side. So which one do I move first? The coefficient in front of our variable that we want is always moved last. So that means we're going to take care of this u first. Remember, when we move it to the other side of the equal sign, we have to do the opposite operation. So right now, we're adding u. The opposite is subtracting u. So we subtract u from both sides. And once we do that, we're left with v minus u on the left-hand side. The u's cancel each other out on the right, so we're just left with a times t on the right. We still want to isolate t. It's being multiplied by a, so we have to do the opposite. We need to divide both sides by a. So we're left with v minus u divided by a equals t. Now we've solved for t. Another example, here's a volume formula, pi r squared h divided by 3. If you'll remember from spiral 1, this is the volume of a cone. Anyway, let's rearrange the formula to solve for h, the height. So this would be an example of, I know the volume of the cone, but I don't know what the height is. So I want to isolate h. That means all these other numbers need to be moved to the other side by doing the opposite operation. So we just have to go through them one at a time. Let's start with the 3. Right now it's divide by 3. So the opposite would be multiply by 3. So I'll multiply both sides by 3. times 3 divided by 3 on the right, those cancel each other out, so I'm left with 3v equals pi r squared h. Now h is being multiplied by pi and by r squared. So I can actually isolate r by dividing by pi r squared on both sides. Pi r squared on the top, pi r squared on the bottom, those cancel each other out. So I'm left with 3v divided by pi r squared equals h. So now I've rearranged my formula to solve for h. Next example, use the speed formula to calculate how long it would take to drive 520 kilometers at 80 kilometers per hour. So I'm going to start with my speed formula. S equals d over t. Speed is distance over time. But this time I want to calculate how long it would take. So that's time. I'm going to rearrange my formula to solve for time. Now a lot of people think, oh, I need to solve for t, so I divide both sides by d. So they end up with t equals s divided by d. And that is completely wrong. The reason people get tricked here is because the variable we want to isolate is on the bottom of the fraction, so they get confused. So anytime you see a fraction, remember, to get rid of the fraction, multiply by the denominator, whatever the denominator is. So for this, let's just multiply both sides by t. So we end up with t times s on the left equals d on the right. Now we can isolate for t by dividing both sides by s. So we end up with t equals d over s. Time is the distance divided by the speed. So now we can actually answer the question, how long would it take to drive 520 kilometers at 80 kilometers per hour? So we have the distance, we have the speed. Time is equal to distance divided by speed. So to solve for time, we have to substitute in our values for distance and speed. So time is equal to 520 kilometers divided by 80 kilometers per hour. That ends up being 6.5 hours. So it would take 6.5 hours to drive 520 kilometers at 80 kilometers per hour. So whenever you're rearranging a formula, the algebra is really the same as what you've done in Spiral 1 and Spiral 2 for solving equations. You're just doing the opposite operation. And if you have questions about this or you're struggling, please let me know and I'll do my best to help.